So today we're going to look at Pythagoras Theorem. So Pythagoras Theorem states that for all right angled triangles, the square on the hypotenuse is equal to the sum of the squares on the other two sides, also known as a squared plus b squared equals c squared. So what does that mean? First of all, we're dealing with a right angled triangle, which is denoted by this symbol here. So that means it's a 90 degrees angle. So the first thing we have to do is label our triangle. So we have A and we have B. It doesn't matter which you use, it could be B here or it could be A here, but it's very important that we have C here. It has to be opposite the right angle, and this side here is known as the hypotenuse. And it can also be used simply hype, just a shortened version of hypotenuse. So there we have, we've labelled the triangle. We have A, B and C, and Pythagoras states that A squared, so that's the length of A here squared plus the length of B here squared will equal the length here of C squared. So we're going to look at some examples and to show you how you would use the formula A squared plus B squared equals C squared. So first of all, we want to find C. So the first thing we do, we label the right angled triangle. So we have A, B and C. Remember, C is always across from the right angle. Also, another good way of remembering how to label C, C will always be the longest side of the right angled triangle. So we know that A is 3 and we know that B is 4. And what we want to find out is we want to find out the length of C. So we know that A squared plus B squared equals C squared. We simply plug in what we have. So we know A to be 3, so we have 3 squared, plus B, which is 4, 4 squared equals C squared. So 3 squared gives us 9, 4 squared gives us 16, and that gives us C squared. The 9 plus the 16 is 25, so 25 equals C squared. But we don't want C squared, we want to find out C. So we have to find the square root of both sides. So the square root of 25 is 5. C squared, the square root is simply C. So there we have it. 5 equals C. So C equals 5. So the length of C is simply 5. Now what if we didn't want to find C? What if perhaps we wanted to find the length of A? So again, we do exactly the same as before. We have our right angled triangle, which we label A, B and C. And we want to find A, so that's what we're after, so put a question mark here. We know C to be 5. We know that B is 4. So we simply write out A squared plus B squared equals C squared. A squared we leave as it is because we're trying to find A, plus B squared, which is 4. So 4 squared gives us 5 squared. So A squared plus 4 squared is 16 equals 5 squared is 25. So we have A squared. Now we have 16 here, so we want to remove 16 from the left hand side to leave us with A squared. But if we remove 16 from the left, we also have to remove 16 from the right. So A squared equals 9. So A simply equals the square root of 9, which gives us 3. So side A is 3. So lastly, what I'm going to do is find B. So again, exactly the same as before. We have A, B and C. We know C is 5. We know A is 3. And this time we want to find out B. So we write out the formula. A squared plus B squared equals C squared. We know A squared is 3 squared plus B squared is what we're trying to find out. So we leave it as B squared and equals 5 squared. So 3 squared is 9 plus B squared equals 5 squared, 25. So again, we want B squared on its own. So we take away 9 from the left hand side, which means we have to do the same to the right hand side b squared equals 16. So b is simply the square root of 16, which gives us 4. So there we have it, b is 4. So that's how you use Pythagoras Theorem. And a simple way to check is 3, 4 and 5. This is actually a scale diagram. So there we have 4. So 1 inch per unit. So we have 4 along. We have 3 down. And all going well, this should add up to 5. And there you go, 5. So a squared plus b squared equals c squared, and that's an explanation of Pythagoras Theorem. I hope you've enjoyed the video. Thank you.